Hello all, today we are covering both parts 6.3a and 6.3b for tests for polygons. You guys will be able to recognize the conditions that ensure a quadrilateral is a parallelogram and prove that a set of points forms a parallelogram in the coordinate plane. So we have this warm-up. We will need it for the second part mostly of finding the slope and finding the distance between 2 points. So if you recall, the slope equation is the change in the y's over the change in the x's. Maybe come up here and mark out which is which. And then plug them in. So 3 minus a negative 4 over negative 5 minus 1. That is positive 7 over negative 6 for our slope. And then for the length, we'll use our distance formula. We'll plug in our numbers once again. So we get 3 minus a negative 4 squared plus, oops, I put my y's in. I should say we will have negative 5 minus 1 squared and then 3 minus a negative 4 squared based on the order that I had them in when I wrote the equation. Honestly, either way, we'll get the same solution, but I just don't want you to get confused between those two. Simplifying your parentheses and then take the square root. So we end up getting negative 6 squared, which is 36, plus 49. So that is the square root of 85, which is approximately equal to 9.21, I believe. Let me check that real quick. Yes, 2.1. The 9 after that makes it round up to 9.22. All right, so if we look down here, that's review. We'll get to what that means in just a little bit. So we have theorems, conditions for parallelograms. So 6.9 is both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So these guys are congruent, these guys are congruent, then it's a parallelogram. 6.10, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if these two are congruent and these two are congruent, then we have a parallelogram. If the diagonals of a quadrilateral bisect each other, so they cut each other in half, then the quadrilateral is a parallelogram. And then if one pair of opposite sides of a quadrilateral is both parallel and congruent, so one pair of sides is parallel and congruent, then this is a parallelogram. So we are going to prove specifically 6.9, where we have that the congruences make it a parallelogram. So we have a quadrilateral, four-sided shape, ABCD, with sides congruent. So that is given to us. And then our statement's already given to us, and so is the next reason. We are going to construct a segment BD. Now before we just said that we know 2 points make up a line, so we can make that line exist there. Then you'll notice that we have BD congruent to itself, if you recall. That is the reflexive property of equality. And then if you can focus in on the triangles that we have formed, we have triangles congruent by our side, side, side. Then if you recall, oopsie. And if you recall, if the triangles are congruent, corresponding parts of congruent triangles are congruent, or CPCTC. So those angles have congruent pairs, as you'll see that I marked. Then, okay, here's the biggest step. Since then, this hasn't been too bad, but we have another step to go here. We need to now say that these are parallel, and you're probably thinking, hold up, how do I say they're parallel? Well, if you look, we have two lines that I just made a little darker and a transversal. And notice how there's congruent angles there. So by the converse of the alternate interior angles theorem, we have parallel sides. So these two sides are parallel. We could do the same thing with that transversal, and these two sides, we once again have these angles that are alternate interior. So by the converse of the corresponding angles theorem, we know that AD and BC are also parallel. So then ABCD is a parallelogram by the definition of parallelogram, because we know by the definition two pairs of opposite sides are parallel. And we're done. And then this next slide, that's just a repeat. I'm not sure why it got repeated, so no need for that. We'll come to the next one. Determine whether the quadrilateral is a parallelogram. Justify your answer. Well, we did just have all those theorems. I would say the first one, part A, is yes, because opposite sides are congruent. I'm going to go ahead and go to C. This is also a yes, because the diagonals bisect each other. They're cut in half like this. They bisect. So this is a parallelogram. It's one of our theorems that we just added. Now, B and D, as is, I would say it's a little iffy to say yes. But on each of these, we can figure out that they are parallelograms based on one of our theorems. In this case, part B, there's a bunch of different ways we can do it. We can say, first of all, one way is by the third angles theorem. These third angles must be congruent. So then we can say that opposite angles are congruent. That was one of our theorems, and because opposite angles are congruent, it's a parallelogram. That's one way we could say yes. We could also do that alternate interior idea that we just did with our last problem, meaning that these two are parallel and that these two sides are parallel. That would be a parallelogram. So there's quite a few different ways that you could state yes for this, but you can't say yes without going through those ways. So I'm going to say yes, but must use third angle theorem to get opposite angles congruent. Now, obviously, I did say there's other ways that you can say that too, but that's just one way. And then this last one, D, we haven't covered it yet, but there are 360 total degrees in a quadrilateral. That is kind of easy to see if you realize that if you split this into two triangles, each triangle has 180 degrees. you add that together and you get 360. So if you do some math, this remaining angle would be 120 degrees. So that means, yes, obviously after we did a little bit of work, we have opposite angles congruent. Okay? And then we can do some math, find x and y, so the quadrilateral is a parallelogram. If we want to make it a parallelogram, opposite sides have to be congruent, so we just set them equal to each other. Now, thankfully, we don't have any crazy stuff with the x's and the y's. We don't need to solve for any system or anything, but we'll have to get there in just a minute. So go ahead and solve. I have to do some distribution here. So we end up getting that x equals 7. And then that y equals something. I believe 5. Oops. Yes, y will equal 5. You could plug those in, check to make sure that the segments are actually congruent to each other. But because we solved, they should be. Similar thing here, find m so that the quadrilateral is a parallelogram. Once again, because these are already parallel, these sides also need to be congruent, and then it will be parallelogram. So we have 4m plus 2 equals 3m plus 8. And solve. So m will equal 6. Alright, now here's where it gets a little crazy. We know if this is going to be a parallelogram that these two have to be congruent and then these two have to be congruent to each other. But if you notice, there's x's and y's and we can't set 3x equal to 2y unless we are going to solve a system. So I'm going to do that. 3x equals 2y and x plus y equals 2y minus 2. Now you'll have to think back to Algebra 1 here, but I'm going to use substitution. I'm going to solve for x on this second equation. So x equals y minus 2. Now if I'm going to solve by substitution, I'm going to plug this whole thing in for this x. So I'm going to have 3 parenthesis x minus 2 because I'm replacing this x with this information right here equals 2y. Then I'll distribute. So 3y minus 6 equals 2y. And then I will finish solving. Now this works because the x's and the y's in the whole problem have to be equivalent to each other. So we can set up a system to solve for them. So y is equal to 6. That means I can plug that back into any of the y's and solve for x. So I'm going to say 3x equals 2 times 6, or 2 times y. And then 3x equals 12. So x is equal to 4. So one's a little more difficult, but we still just needed to solve for the x and y variables, but through a system. All right. Now here's where that intro problem comes in. We have coordinate geometry. We have quadrilateral QRST has those vertices. Determine whether the quadrilateral is a parallelogram. So this time we're going to justify our answer using the slope formula. So basically we need to make sure that the slope of this line is parallel to the slope of this line, and that the slope of QR is parallel to the slope of TS. So we have our slope formula. That's our question here. Maybe I should leave those on there. our slope formula is y2 minus y1 over x2 minus x1. With the picture, it really is just easy enough to count, but they did say with the formula, so we're going to do it. So I'm going to find the slope of RS first. So there's my R and my S value. I'm going to plug them in. And then solve. So it looks like the slope is 4. Maybe count it. We rise 1, 2, 3, 4. We run 1, so that looks good. That is the slope of RS. Now, we want to make sure the slope of QT is the same. So Q and T, I'm going to say 3 minus a negative 1 over negative 1 minus a negative 2. So we have 4 over 1, which reduces to 4. So the slope of QT is good to go. They match up, so that part is fine. Let's check the slope of QR and ST. They have to also match up, or else this is a no-go. So we have QR and we have ST that we need to check this time. So we have 1 minus 3 over 3 minus negative 1. So that's negative 2 over 4. That is negative 1/2. That is the slope of QR. Let's check that by counting. I go ahead and rise 1, run 2 to the left. Yep, seems good to me. And then check the slope of ST. So we have negative 1 minus negative 3 over negative 2 minus 2. We end up getting 2 over negative 4, which also reduces to negative 1/2. So our slope of ST also checks out. So we're good. This is a parallelogram because those sides are actually parallel like we marked on our picture. Sweet. Cool, cool. Now we're going to do a very similar thing here. We have to actually graph it ourselves though. But instead we are going to use the distance formula. Perfectly valid. So we're going to graph EFGH. So E is negative 2, 2. I'm going to go ahead and label that because that'll be helpful for me in a minute. F is over 2 up 0. G is over 1 down 5. And H is negative 3, negative 2. So let's see, can I draw this in well? I'm gonna do my best I can. Okay, so don't go off of just what the picture looks like. Actually solve for this. So I know EF needs to be congruent to HG, and FG needs to be congruent to EH. So EF, find the distance. It does take a little bit of work here, but you got it. Okay, so we have the square root of 20 here, which is approximately equal to 4.47. Okay? So let's then find HG. So we need to find the distance of HG then. So h -3 minus 1 squared plus -2 minus -5 squared. We have -4 squared plus 3 squared. What do y'all notice here? We end up getting 16 plus 9. That is not the same thing. If you also look at your slope for these just by the picture, make sure you graphed it correctly first of all. This is not the same slope either. It is different slopes and different distances. We don't even really have to check the EHFG distances. You can if you want, but your distances are different here. So we know this is not a parallelogram because these sides are not congruent lengths. So not congruent, I don't know, EH and FG might be congruent, but now it doesn't matter because our two opposite sides, EF and HG, are not congruent. So then in summary, we have these possibilities to prove that a quadrilateral is a parallelogram. You can show that both pairs of opposite sides are parallel. So that would look like, these are going to be bad pictures, I'm sorry. That would look like, parallel. Non-congruent parallel. You can have that both pairs of opposite sides are congruent. There we go, that's nice. You can have that they're congruent like that. We can have that both pairs of opposite angles are congruent. I'll draw this one over here. Oh, that one is not as nice. Good enough. Opposite angles are congruent. And then we can show that the diagonals bisect each other. Draw diagonals in here. Obviously not quite a parallelogram. They bisect. Or you can show that the opposite sides, one pair of opposite sides, is both parallel and congruent. And those are all ways that you can show that a quadrilateral is a parallelogram. All right, have a great afternoon.